In this video, we will discuss how to convert a Fischer projection formula into wedge-dash formula. That is the discussion. In the previous video, already we discussed how to convert a wedge-dash formula into Fischer projection formula. Let us recollect that. So whenever you have wedge-dash formula, you have to see the molecule between solid wedge and broken wedge, and this will be away from the observer, this will be away from the observer, and these groups should be away from the observer. You can see COOH and CH3, they are attached to broken wedge, dashed wedge. And when you are seeing the molecule from this position, and this NH2 group will be left side to the observer, therefore NH2 should be written left side and hydrogen should be written right side. So these two groups are nearer to the observer, therefore you are using solid wedges, and this is left side, therefore this is left side it is written, hydrogen is right side. And also we can simply convert this Fischer projection formula into this normal lines also we can write. This is just only the representation. But in this Fischer projection formula, whatever the groups attached to the vertical line, they are actually away from the observer. So here this is COOH and this is CH3, and this is the position of the observer. And if you convert this second molecule into Fischer projection formula, it is very clear. So here this is ethyl group, and here also we have ethyl group. They are away from the observer, they are away from the observer, therefore one ethyl group is here, another ethyl group is like this. When you are seeing the molecule from this position, at this carbon, this chlorine is above the plane actually. When you are watching the molecule from this position, this chlorine will be left side and this hydrogen will be right side. And here this chlorine, when you are watching the molecule from this position, this hydrogen is actually above the plane of the paper, but when you are seeing the molecule from this position, this hydrogen will be left side and this chlorine will be right side. So this is the conversion of a wedge-dash formula into Fischer projection formula. But here the actual topic is conversion of Fischer projection formula into wedge-dash. So it is a simple hint, simple shortcut I'm going to discuss. So whenever you have a Fischer projection formula, if you want to convert that Fischer projection formula into wedge-dash formula, you just take the groups attached to the vertical line, that is COOH and CH3, and that is your wish. Drag these two groups either towards the right side or towards the left side, that is your wish. And here you are going to write an alphabet V by using the groups attached to the vertical line COOH and CH3. Those groups are pulled towards right side. As a result, it becomes like this, COOH and CH3. In this process, whatever the group which is present right side in Fischer projection formula, this will be going above the plane, that will be going above the plane. So here this is OH and this will be going below the plane like this. So this is the conversion, this is the conversion. And if you want to convert it back, you have to see the molecule from this position. So there is no point, there is no rule like you have to drag only right side. You can also drag left side. In that situation, hydrogen will be above the plane and OH will be below the plane. So instead of discussing the same example, let us take this one. So here this is a COOH group and this is a CH2OH group. In this example, let us drag these groups towards left side. As a result, you will get a V like this, and here this is the group COOH and this is the group CH2OH. Now another V, so this hydrogen and OH, since these groups are pulled towards left side, the group which is actually left side in Fischer projection formula, that will be going above the plane. So this is a hydrogen and another group that OH will be like this. This is the proper conversion. And even if there are two carbons like this is one carbon, here also we have one carbon like this, same procedure we can, totally there are four carbons. So here this is a CH3 and this is a CH3, this is dragged like this is also dragged like this. As a result, you are going to get something like this. So this is a CH3 and this is a CH3, and here this hydrogen is actually right side, so this is pulled towards right side, so the hydrogen will be going above like this and OH will be below like this. And one more center we have, so here we have hydrogen, so that is hydrogen, it will be like this, and here this is chlorine. So this is the conversion. You can take one more example. So here this is a COOH, this is a COOH, any side you can pull, no problem, like this. So here this is the situation, COOH, here you have a COOH, and this is dashed wedge, broken wedge, here we have dashed wedge, broken wedge. You can see this OH is right side, so you have pulled these groups right side, therefore OH will be here, hydrogen will be here. Here this hydrogen is right side, so that is above and this is below. This is the conversion. And let us take one more example. So here this is a CH3, this is a CH3. Now let us pull these groups towards left side. So left side, as a result it will become like this, CH3 and this is a CH3. Left side you have a hydrogen here. So here left side you have a hydrogen that will be going above the plane. So that is hydrogen and OH. Here left side you have chlorine that will be going above the plane. So here this is a conversion of a Fischer projection formula into wedge dash formula.